let's see these problems. Given 2010, 2011, 2012 up to so on 2018. See, our shortcut is simply by multiplying the numbers and adding or subtracting, you are going to get an answer. If you want to multiply first one 2012 into 2013 into 2017 up to right, if you get an answer after ECET exam only, you will get an answer. See, like these problems, once again I am using elementary transformations. Why we have to use elementary also, you will get like from this one. Okay, like if you follow the procedure, it will take more time to simplify that. We are using simply what I am doing means up to right now we used column operations. Now I am using a row operation, that is I am changing R2 minus R1 from R2 row number 2 నుంచి row number 1 elements ni corresponding elements ni eliminate చేయాలా, and also at a time applying one more, that is R3 tends to R3 minus R1. Once again I am using R1 only, I am changing here R1 is not changed, that's why I am writing rightly 2010, 2011, 2012. What is going to be changed here? Here R2 is going to be changed, R2 minus 1, R2 is nothing but 2013 minus 2013 minus 10 is nothing but 3. Next 2014 minus 2011 is nothing but once again 3. 2015 minus 12 is nothing but 3. Here 2016 minus 2010 is nothing but 6. Here you will get 6. Here you will get here if you observe, if I multiply row number 2 with 2, you will get row number 3. That is if 2 rows are 2 columns are proportional. What is det is going to be what? Det is going to be 0. Simply here the answer is going to be simply 0. Here you will get also 0. ఏమవుతుంది ఇక్కడ 2 rows. Once again how you will get means if you eliminate indirectly. Here if you apply one transformation, just I am applying, how you are getting 0 I will show here. That is if I write R3 tends to R3 minus 2R2, that is 2010, 2011, 2012. Here 3 next 6 minus 2 into 3, once again 2 into 3, 6 minus 6, 0, 0, 0. If proportionality is there, that is one row is 0. Indirectly by using this, if you expand determinant shortcut is only that one. Simply ఏ రోలోనైతే అయితే ఏ కాలంలో అయితే ఇండైరెక్ట్లీ నెంబర్ ఆఫ్ జీరోస్ ఎగ్జిస్ట్ అవుతాయో ఆ నెంబర్ ఆఫ్ జీరోస్ బేస్ చేసుకొని మనం డిటర్మినెంట్ ఎక్స్పాండ్ చేస్తే ఈజీగా ఆన్సర్ వస్తుంది. ఎందుకంటే ఎలిమెంట్ 0 కాబట్టి ఎలిమెంట్ దట్ కో ఫ్యాక్టర్ ఇండైరెక్ట్లీ ఈజ్ గోయింగ్ టు బి 0. దట్ ఈస్ ఇఫ్ యూ ఎక్స్పాండ్ బై యూజింగ్ కాలమ్ నెంబర్ రో నెంబర్ 3, యూ విల్ గెట్ 0. దట్స్ వై 0 into anything is going to be 0. Once again same for this problem, just follow me. Here by using a logarithm properties, log e base e always is going to be 1, and also log a power m equal to m into log a. Based upon this, indirectly always the base is going to be e. Log a power m ante m into log a anukuntunnam. Log e base e is nothing but 1. Here log e nothing is there means indirectly it's going to have base e. Log e base e is nothing but 1. Here if you write 2 into log e base e is nothing but 2. Here you will get 3. Here you will get 2, 3, 4, 5. Once again here I am applying R2 tends to R2 minus R1, R3 tends to R3 minus R1. Now apply, that is 1, 2, 3. First row is not changed. Second row, that is 2 minus 1 is nothing but 1. 3 minus 2, 1. 4 minus 3, 1. 3 minus 1 is nothing but 2. Here you will get 2. If 2 rows or 2 columns are proportional, here also the determinant is going to be 0. Simply you have to remember indirectly here this one, that is if 2 rows or 2 columns are proportional, the determinant is going to be 0. Here simply one more thing I am giving from these problems. If you having sequence of numbers, here see 10, 11, 12, 13, 14 up to so on 18, you will get 0 determinant. 1, 2, 3, 4, 5, 6, 7, 8, 9. up to 9 is there, it's going to be 0. If one number is missing, 17 తర్వాత మళ్ళీ 17 వచ్చింది, అప్పుడు 0 కాదు, it's going to have some answer. If it is sequence numbers, compulsory it's going to be 0. If you check, you can check. If you take any number, you can take. If you take, you will get an answer. Simply, but here the property, you remember this property, that is if two rows or two columns are proportional, then always determinant is going to be 0. Right? We'll see more problems also. Let's see other problems. Let's see in this problem. This is previous ECET question. That is in 2010 you got this question. Simply given this matrix and is asking what is determinant to, and is going to have some options. See, whatever just elementary transformations we can apply, that is by using our property. A non-zero constant is multiplied with row or column of elements or added with another row or column, then determinant is unaltered. You can use that one. Up to right, we use that. But I am giving one more trick here. That is nothing but just I am substituting here in place of x and y and z, just I am taking one value, that is 1. You can take any number, no problem, but it's going to be difficulty when you are performing determinant of that matrix. Just I am taking each and every value as a 1. Now substitute here. 1 plus 1 is nothing but 2. 1, 1, 1, 2, 1, 1, 1, 2. Why? Because x plus y is nothing but 1 plus 1, z plus x 2, y plus z, indirectly 2. Now indirectly by using this, we got this matrix. If you find the determinant for this, nothing we can find determinant easily if the numbers are present, that is 1 into 1 into 1, 1, next to 2 into 2 into 2, that is 8, 1 into 1 into 1, that is nothing but 1, minus 2 into 1 into 1, 2, and 1 into 2 into 1, once again minus half you have to write, but I am multiplying inside minus 1 into 1 into 1, that is 2. Here 10 minus 6 is nothing but 4. Now check in the options by substituting these values. If you substitute in place of x equal to 1, y equal to 1, z equal to 1, first option is going to be 1, second option is going to be 2, third option is going to be 3, fourth option is going to be 4. This satisfying only one option, that is going to be your fourth one. Simply by cross checking also you can get the answers. Right? Like you can take any values. For suppose if you are getting like this, in previously we got a, b, c, 1, 1, 1, b plus c, c plus a plus b. Like that problems also you can take in place of a and b and c. You can take any number. If you write, if you substitute, after substituting that, if you find the determinant, then you will get same answer whatever just we got. Right? You can check like this also. Let's see more problems. Let's see in this problem. It's a very important problem. It is also so many times repeated. In ECET 2014, you got this problem. Okay, in every book in matrices topic is there, means you will get this problem. Indirectly, what is that? If omega is cube root of unity, then this matrix in complex numbers you will get actually 1 cube roots, and indirectly square roots means you are going to have 2 roots. Cube roots means one is having 3 roots. One is 1, another one is omega, another one is omega square. Actually it's not omega, we are treating as omega. Actual value is going to be, that is minus 1 plus I root 3 by 2. It is going to be minus 1 minus I root 3 by 2. We are treating as this is omega square. Either you can treat this is as omega, but you will get this is omega square. That is a square of this value is going to be this one, or square of this value is going to be this one. See, always 1 is a unity cube root, that is cube root of 1 is going to be, indirectly it's going to have 3 roots. 3 roots, square root is nothing but 2 roots, 3 roots means nothing but 3 roots, indirectly 1 omega square. By using indirectly it's going to have some properties, that in that we have one result 1 plus omega square equal to 0. If you add these 3 values here, you will get 0. 1 plus minus 1 by 2 plus 1 by I by root 3 by 2 plus minus 1 by 2 plus 1 by 2, indirectly is going to have plus I root 3 by 2 minus I root 3 by 2 cancel. Minus 1 by 2 minus 1 by 2 minus 2 by 2 minus 1. 1 minus 1 is nothing but 0 only, na? This is a main property of cube root. By using, we are going to use this property here. How means? Simply what I am doing means, in place of C1, I am writing C1 plus C2 plus C3. That is now, come on, see, I am adding these three values, that is 1 plus omega square. In place of C1, 1 plus omega square. In place of C2, omega plus omega square plus 1. Here, omega square plus 1 plus omega. Column 1 is over. Next column, that is omega square 1. Omega square omega 1. See, by using this property, 1 plus omega square equal to 0. If you replace here 0, that is 0, 0, 0. Omega square 1. Omega square omega 1. If you expand by using column number 3, 0 into something always is going to be 0. The answer is going to be 0. It's a very important problem. So many times you will get. And ECET also, you got this one so many times. If you are getting this problem, simply you can write as 0. Okay, let's see more problems and some results also. Yeah, let's see those.